Okay, 7.2, modeling and solving systems of linear equations. So it's going to be very similar to 7.1 in terms of solving it, but in this case you might get word problems and you're going to have to model an equation, or most cases two equations that model that situation. Okay, so let's go through this. Linear systems can be used to solve real-world problems, application problems if the quantities involved change at constant rates. So constant rates, remember, it just means it has a slope on it, right? The slope-intercept form of a line can be used when you know the rate of change, m, right? So m is the slope, and the initial value, b, which is the y-intercept, right? Um, okay, so whenever you get these equations, you want to try to afterwards probably put them in the form of slope-intercept form, y equals mx plus b. So how do we come up with these equations? I think this is kind of grade 8 stuff, but let's take a look. So model each situation using a system of linear equations, and obviously the answers are here, but we'll kind of go through this. So the sum of two numbers is 42. So that's pretty straightforward. So the sum of two numbers, which we don't know, and again, we're just going to use x and y variables, so you can use any letter really. So first number plus the second number will give you 42. And the second equation, you can read by the second sentence here, the larger number exceeds the smaller number by 8. So, and by this statement, you should come up with something like this, y equals x plus 8. So whatever the larger number is, it's larger by how much? The smaller number plus 8. And you get your two equations. Okay. So based off these two equations, you can solve this by either, we've talked about graphically, you can move the x over, minus x, and it'll be y equals negative x plus 42. 42 would be the y-intercept, negative 1 would be the slope, and see where they intersect the two slopes. Another way to do it is you can do substitution as well, which we're going to do in the second, no, chapter 8, right? So we'll do that in the next chapter. Okay, so B, Jim has a mass that is 10 kilograms less than Tony's mass. So straightforward, Jim, let J mean Jim, and I got a highlighter here, so we're looking at this equation here. And then T, who is going to stand for Tony. So whatever Jim's mass is, it's going to be 10 less, right? So T minus 10. So that's the first equation. Second equation, together they have a mass of 105. So that's pretty straightforward. J plus T equals 105. 105 kilograms. So you got your second equation. That's all you're doing for this example one. They're just asking you to come up with equations. The total value of nickels and dimes is $3.75. So what equation would you come up with? So how many nickels there are? Let n stand for nickels. So how many nickels there are times 0.05, because a nickel is worth 5 cents, right? Plus 10 cents times d, how many dimes there are. And we're putting 0.10 because that's how much a dime is. And this value, cash value, would equal the total amount of money, which is $3.75 in this case. So that's equation 1, right, from the first sentence. And then equation 2, there are 3 times as many nickels as dimes. So straightforward. So 3 times d is going to give you how many nickels there are. Because if there's 3 times as many dimes as nickels. So if there's 5 dimes, there's 3 times as many nickels as dimes. So if there's 5 dimes, 5 times 3 gives you 15. That would be 15 nickels, right? Okay. 3 pens and 3 notebooks cost $6.90. Okay, and that's pretty straightforward. So 3 pens, so 3 times p, plus 3 notebooks, 3 times n will give you $6.90, right? And what these p and n is going to be, they're the variables representing the cost of a pen and a notebook. Okay. Second sentence gives you the second equation. 2 notebooks and 1 pen cost $4.10. So same idea here, but there's different quantities of notebooks and pens. It equals $4.10. Okay. So this sort of thing is what you're going to have to do in this section. Is you're going to get some kind of word problem, or some kind of sentence, couple sentences, and you're going to come up with 2 equations. Okay. So it's just one extra step compared to 7.1. Okay, so let's look at this example, and it looks a lot of work that they did. But we'll read the question together, and then I'll kind of explain what's going on here. So sales clerks at an appliance store have 2 payment options. The first option is to work for 6% straight commission on all sales. And if you don't know what commission is, it's a method of making money where instead of getting paid like an hourly wage, like $15 an hour, $16 an hour, whatever, you get money based on how much material you sell or how much product you sell. So in the first case, they're working for 6% straight commission. And straight commission means that you're not making any hourly wage. All your income is based on how much you sell, right? So if you sell a lot, if you're a good salesperson, you can make a lot of money. And if you're not so great at selling stuff, then you're not going to make much at all. Okay, the second option is a weekly salary of $250. So there's like a base salary. So no matter what, you get $250 plus 2% commission in all sales. Explain which option is better. So what would be better if you're getting just 6% commission, straight commission, or if you're getting less commission, only 2%, but you're also getting that $250 guaranteed each week. So in order to compare these, it might help to graph it out. So these equations, well, here are the two equations. There's one here and there's one over here. And how did they come up with these equations? So this is for the straight commission, right? So E stands for earnings, S stands for sales. So how much they earn is going to be a 0.06, and it's because we took the percentage and we made it into a decimal by dividing by 100 times of, so 0.06 times how much they sell is going to be how much they make in commission. Okay. In this case here, earnings is going to equal the base salary, 250, plus 0.02 because it's 2% commission times how much they sell. Okay. Also note that this is also kind of looks like the slope intercept form, although this is kind of the other way around, which it doesn't, we can just kind of place it the other way around if you like when you're writing it out. So 0.02 is going to be the slope, right? And you can kind of think of the S as the X, right? And this E is kind of like the Y value. And the 250 is the Y-intercept. Okay, so in this case, there is no Y-intercept, meaning the Y-intercept is 0. Okay. So you can kind of see that on the graph here, and I'll kind of go over what the table of values is. So in equation 2, you're starting at 250, the Y-intercept, and then the slope goes out. And then in this case, you're starting at 0. Slope goes up, but the 0.06 slope is much steeper, right? So there's more of an incline, a greater angle here than the slope over here, which makes sense because the larger the number, the bigger the slope, right? Yeah, and they intersect at this point. So how do you draw this graph? So this is what if you don't know how to plot the graph, you'd have to make a table of values, right? So they just chose, going up by 2000s, and it might be a little bit of trial and error if you have to do a question like this and graph it, where you're going to have to choose, certain certain values and see. Basically, our goal here is to see where the earnings kind of cross, right? Where do they intersect? So you might plug in like 0 for earnings, and then 100, then 200, then 300, then 400, then 500, and then see what you got. Actually, you would probably plug in the sales because it's equal to earnings. So here, you might try like 1,000, 2,000, 3,000, 4,000, and okay, this graph might be too squished, so then you might try 2,000, 4,000, 6,000, 8,000, 10,000 like they did, and you get your earning values. So they did the same thing from two equations, and then they just plotted those points, right, based off the equations. So that's one way to do it. Another way to do it would be to just use the equation itself, right? You start at 250, and then, rise over run. So if you go 0.2 up, and then you're going to go the right 1. But that's going to take forever to do. So you can also multiply the slope by, say, 100 or 1,000. Maybe 1,000 might be better, right? So you go up by 1,000, it would go up by like 20 and over 1. So that sort of thing. But I think the table for this question, table values might be a little bit better. Yeah. And then you're just going to spread it out to kind of fit this area, right? And also remember the y-axis is going to be the independent variable, or sorry, that's incorrect. The y-axis is going to be the dependent variable, and the horizontal axis, the x-axis, is the independent, right? So in this case, earnings is going to be in the y because how much you make depends on how much you sell, right? So that's why it's arranged this way. So once you've got the graphing kind of done, and again, if you had a graphing calculator, which you don't really need in grade 10, you just input these equations and the graphing calculator will graph this out for you, right? And you know that this section right here where it intersects is kind of like an important point. So going back to the question, what is the question in this question? Is explain which option is better, okay, between these two. So this is kind of like a trick question where one option is better than the other depending on how much sales you're getting, right? So if you're not very good at sales, you're probably going to want to take the option 2, the graph of here, because if you're not good at sales, it starts at 250, so you still get your base salary, right? So the base salary, even if you don't sell much, is still better than the other option, okay? Until you hit this point, okay? So at 6,000, so once you hit, well, it's actually a little bit more than 6,000, but once you get a little past 6,000 sales, then it's better to take the higher commission rate, right? Because you're selling enough to justify starting at 0 base salary. So yeah, so to answer the question again is it's better to have the 250 base salary equation unless you're able to sell more than 6,200, and then it's better to have the other, the commission, right? And that's pretty much all it says for option 1 and 2, so I kind of explained it. Yeah. Okay, so example 3, and I think this is it for 7.2. Another word problem here. And when you get these word problems, again, your first goal is to come up with an equation or 2 equations, and then you're going to have to figure out, either use a table of values or use equations themselves to graph it out onto a chart, and then just be able to understand the graph as well, like what's the important points and what is the graph actually telling you. Okay. So let's go into this question. Example 3. 2 pools start draining at the same time. The larger pool contains, and these numbers will change just to make the math a little bit easier, so instead of using these numbers. So the larger pool contains 55,000 liters of water and drains at a rate of 250 liters per minute. So I guess this is a pool of 55,000 liters, and it's every minute 250 liters is draining out. The smaller pool contains 35,000 liters of water and drains at a rate of 100 liters per minute. So you can see that the smaller pool has less water, but it's also draining at a slower rate, right? The slope is less steep. The larger pool has more water, but it's draining faster, okay? So question A, model the draining of the pools algebraically using a system of linear equations. So this just means write an equation for both scenarios, okay? So here we got W, right? Just, you can use any letter you want, but it kind of makes sense to use W because that represents how much water there is left in the pool. So equals, so for the bigger pool right here, oh yeah, it does highlight, cool. Guess for this equation here, we start, and again, this is kind of backwards, so it is looking like it's Y equals mx, so this is like mx right here, plus b, so kind of backwards. This is your y-intercept, the b, and this is your slope, the negative 250, right? But anyways, you're starting with 55,000 liters of water in the pool, and every minute, so minus 250 times t, and t would be, I guess, stand for time in units of minutes. So every minute 250 liters is getting drained out. So same sort of thing for the equation 2. The water is equal to, it starts at 35,000, but every minute minus 100 t, it decreases by 100 liters per minute. Okay. Represent the linear system graphically. Describe how the information in the graph relates to the pools. Okay. So again, what's the independent variable? That's the first thing you start out with. It's the x-axis, and the dependent variable is the y-axis, right? And then where do we start? So the chart, this top portion you don't really need. You start from 0, and the highest it'll go is about 55,000. So you can go from 0 to 6,000 up here, because you know it's draining, and the water's going away. So if the water's going away, the highest either equation would be 55,000. Okay. So once you've done that, you're just gonna have to figure out how much time, how should you make your scale here? Should it be here? You can see that they did every square is 20 minutes, right? 20 minutes, 20 minutes, 20 minutes. But why isn't it, you could have done 100 minutes, 200 minutes, 300 minutes, going up by hundreds, going up by tens. That's when you use a data table and just plug in certain time values for t and see where the pool levels go to, right? And then, yeah, a bit of trial and error. Or if you had a graphing calculator, you can simply use that, but you're not really supposed to, or you don't really need a graphing calculator in grade 10. Okay, once you've got the graph set, right, make sure, again, the y-axis is labeled with the units, the x-axis is labeled with the units. You make sure your slopes are labeled so we know which is which, right? So that's about it. That's how you graph it. And then so describe how the information in the graph relates to the pool. So we kind of talked about it. 55,000 is a bigger pool. It's draining, it's draining, it's draining at a faster rate than the small pool, which starts at like 35,000. And it's draining at a slower rate. And at this point where they intersect, this is how much, this is the time, right, when both pools have the same amount of water, right? The bigger pool was draining faster, and then at a certain point that they had the same amount of water. And after this point, the bigger pool actually has less water because it's draining still at a faster rate. The smaller pool has more water in it. Okay. So though the larger pool has more water, it drains at a faster rate, so is empty sooner. So that's kind of what we talked about. And that's all they really want you to do. So again, when you get these questions, first, read the word problems carefully, set up your two equations, and then if you want to graph it, you can either, change it to the format of y equals mx plus b. If you need to create a data table of values like this, you might need a trial and error, try a few of them, and you'll get it. And that's pretty much this section. Okay. All right. Let's. If you're done, you can jump in and watch the notes on 7.3 now.